Alright, so today we're going to be talking about projectile motion. So I have this cool little problem. A toy car runs off the edge of a table that is 2.350 meters high. The car lands d, distance, equals 1.420 meters from the base of the table. And our two questions are, how long did it take for the car to fall? So that's going to be in seconds. And how fast was the car going on the table? So that's going to be in meters per second, right? Velocity. So essentially with projectile motion problems, you want to first figure out what you're given and what you want to solve for, and then you just plug stuff that you know into these equations. This is the motion equations, but they've been divided into horizontal and vertical motion, right? So the problem tells us that the height is 2.350 meters high, and the distance away from the edge of the table is 1.420 meters. So why don't we draw a nifty little diagram? Because I find that diagrams always help me visualize things and really sort of understand what I'm trying to solve for. So let's say this is our table. Here's our little car. It's traveling this way, and it's going to fall somehow like this. So this distance here is 1.42 meters. And our height is 2.350 meters, right? So what we're trying to solve for is how long did it take for the car to fall. So how long did it take from the car to hit, from this position to go to this position, to the ground, right? So in seconds. And then the second part we're looking for is how fast was the car going on the table. So we're looking for velocity initial, but not just the velocity initial of any motion. We're looking for the horizontal velocity initial, right? And that makes sense because as this car is traveling, there is no vertical velocity. It's not going up. If this car had been shot out of a cannon, instead, then it would have had both horizontal and vertical motion. But since it's simply going horizontally across the table, it's only going to have horizontal velocity, right? So let's start solving for stuff. I should also add that we also know what acceleration is. Acceleration is 9.8 meters per second squared, right? That's just gravity. So the car is going to fall down, right? So we're looking for how long did it take for the car to fall. So we find an equation where we know most of the variables except for delta t, right? And then we just solve backwards, right? So we know what we'll rewrite this as delta y and this as delta x. So let's pick one. We could do this equation. So delta y equals v initial times delta t plus 1/2 acceleration times delta t squared. Now I should also point out that anytime you separate the motion equations into horizontal and vertical, you're only focusing on the vertical parts. So here, this would be the vertical initial velocity. And like I've said, that doesn't exist. So we can basically just cross out this entire part of the equation, which makes it easier, right? So now we have delta y equals 1/2 times acceleration times delta t. And now since we have delta y and acceleration, we can solve backwards for delta t, right? 2.350 meters equals 1/2 times 9.8 meters squared times delta t squared. Now if I can find my calculator, there it is. Let's see, 2.350 divided by 1/2 times 9.8 is approximately 0.479 seconds, and that would be seconds squared, because the meters and the delta t squared. Now we have to square root that, and that would be delta t equals 0.693 seconds, right? So now that we know that, we've solved for the we solved A. How long does it take for the car to fall? And now we can use the information we found from the first part of the problem to solve for the second part of the problem, which is why it's pretty important to solve these problems sort of carefully, so that if you mess up the first one, you don't mess up the second one too, right? So, add that to our list of known values. Alright, now let's solve for how fast is the car going on the table. So that's V initial in the horizontal motion. So now the only horizontal equations that have delta x and time is this one. So we're going to use that one. Delta x equals V initial times delta t. We know delta x, 1.420 meters. We know change in time, 0.693 seconds. So we can solve for V initial, horizontal. 1.429 divided by that number, we end up getting 2.050 meters per second squared. And that is the answer to B. And then the answer to A is 0.693 seconds. Okay, and that's really how simple it is to solve these projectile motion problems. Ooh, it's the end screen. Click on one of these links to be directed to that playlist. And don't forget to subscribe!